Hi. Okay, I'm back. So this is where I left off in the previous video. I have a genetic algorithm attempting to find the shortest path between all of the cities, which are these just two-dimensional points, with the traveling salesperson problem. So what I'm doing in this version that I made in the previous video is I am just looking at the orders, the paths that had the shortest distance, and I am cloning those for a new generation and then kind of like shuffling some about randomly. But I am not actually applying crossover. So one thing I want to do in this video is apply crossover. So in other words, I have a set of points like 1, 2, 3, 4. Let me write those again. 1, 2, 3, 4. And one order might be something like this. And another order might be, something like this. So what I'm doing right now is we can see, I don't know, this it's hard to see. These aren't. So let's say this has a distance of some number that maps to a fitness probability score of 0.6. And this has a distance of some number that maps to a probability score of 0.4. What I'm going to do for the next generation is I'm going to make two. If I only have a population of 2, I'm going to make 2 new orders. Can you guys hear that? Some loud noises in the hallway. Okay, I'm going to make 2 new orders, and I'm going to make these 2 new orders out of the ones that have done the best. So I'm going to throw a dart at the wall. And, I hope I don't ruin this beautiful marker. I have a 40% chance, this isn't really where I really have a 50% chance of hitting either. I have a 60% chance of picking this one, a 40% chance of picking this one. If I pick this one, I'm going to clone it to the next generation, but maybe swap 2 points. So instead of, the order goes from here to here, I'm going to go from here to here to here then, or something. And then I might pick this one. So I'm just doing, I'm creating new elements of the next generation from the previous generation by making a copy. What I want to actually do is have a mechanism for how I could combine 2 of them into a new order. And that's what I'm going to look at in this particular video. Now, before I do that, let me see if I can just add some simple little improvements to this. So for example, one thing I want to do is I'm only drawing the best ever. And so what might be useful for me to also draw, just to sort of see how this is working, is what I could do is translate to the bottom of the window, and I'm going to do this. I could also draw just the current best. So where am I evaluating the best one? I'm doing that here. So I could have another variable which is just, where I have a variable called best ever. I'm going to have like current best. And what I'll do is here I will also say current record equals infinity. And if I will now say also, I will also check if D is less than current record, then current record is this, and current best, or best current, I can't remember what I called it. What did I call it? Current best. Current best is this. So I don't know if this is that useful, but I thought I would add it so I can also see now. This is me drawing the best ever, and now I also want to draw the current best. So let's run this, and we can see that it's, the population is doing a lot more stuff internally, but every time, eventually, as it's trying new eyes, it sometimes gets a better one. So this is a little, at least we have something more to watch here to sort of see that it's continuing to animate, continuing to try and guess future options. Okay, so now, how else could we improve this? Let me look and, first of all, one thing that I did kind of weirdly, which doesn't make too much, which I feel like needs, the mutate function needs some improvements. So what mutate does is every time it clones something, it just swaps 2 elements. But I do have this idea of a mutation rate. So I don't know, I sort of feel like what might make sense is for me to say well, let me have a loop that goes through the total number of cities. and then just says, like, if a random number 1 is less than the mutation rate, then perform this swap. So this is just a way for me to say, like, if there's 10 cities, then maybe I have a chance of like doing 10 swaps, but maybe I only have a 10% chance of doing a swap or something for any given city, for any given spot. I don't know. I'm not sure if this really makes a lot of sense, but I am going to try it this way. And then where I say mutate, I could give it like a mutation rate. So if I give it a mutation rate of 0, we would see that it's never, ever, ever going to get any improvements. If I give it a mutation rate of 1, we're going to see it's just like really, really, really making a lot of swaps all the time. I don't know if that's so optimal. Maybe I would try something like a mutation rate of 0.1, and maybe that's like a little bit better. So I don't know what's going to be an optimal mutation rate, but at least I have some structure for saying do more random shuffles or less random shuffles, and that could probably be improved. Okay, so now what we need to do is add crossover. So first, I got to think about how we're going to do a crossover algorithm, but right now what I want to do before I do that is just find the place in the code where I'm going to do crossover. Okay, so this is where I make, this is where I create a new order I pick one from the population based on its fitness, and then I mutate it and add it. So really what I want to do is I want to change this now to be order A and order B. I want to pick 2. Order A and order 2, and then I want to say var order equals crossover order A and order B. So what I want to do is I want to pick 2, cross them over, then mutate, and then get a new. Now, whether this is actually going to improve the performance of this, it's unclear to me, but certainly this would be something that's typically found in a genetic algorithm and worth giving a try. But here's the really tricky thing. So I'm going to come over to the whiteboard, and now we have to discuss how we're going to do crossover. So remember, let's say these were the orders, 0, 1, 2, 3. These are the index values, 0, 1, 2, 3. So one order is 0, 3, 1, 2. That's one order. Another order is 0, 2, 3, 1. Okay, so typically, if you've watched any of my other videos about genetic algorithms, the way that you could perform crossover with 2 arrays of genetic information is to take half of one and half of another and put them together, in which case my new order would be 0, 3, 3, 1. But there's a major problem here. This is invalid. In other genetic algorithm examples that I've done, there's no such thing as an invalid DNA array because it's just a bunch of numbers. But this is a special kind of DNA array that must have every single instance of each index once and only once. So this kind of splitting it half and half won't work. The flipping a coin algorithm won't work. I can't say, pick A or B, 0, pick A or B, okay, pick B, 2, pick A or B, okay, pick A, 1, okay, pick A or B, pick B, 1. Once again, even if I'm flipping a coin, I now have 1s in 2 places and I don't have 3. I'm sure there are lots of strategies for doing this kind of crossover, and I would love to hear from any of you of your own ideas of what might be a good technique. But here's one that I'm going to try. One way that I could do this, I shouldn't have erased that. Stop. I'm going to put, okay. 2 hours in is where I start to lose it. Okay. I erased, okay. Mathieu, please save me. Okay, one order again is 0, 3, 1, 2. Another order is 0, 2, 3, 1. So what if I take some random part of one of these? So let's say I just randomly decide I'm just going to take 3, 1, and I'm going to start my next order 3, 1. I have 2 empty spaces I need to fill. Well, what if I then said, okay, I'm going to take, this was a bad example because I'm going to, let me just pretend this order is a different one. Because I want to make an example that's a little bit, that actually has something you can follow. So So this is 0, 1, 2, 3, and I'm going to go 1, 3, 0, 2, 1, 3, 0, 2. So what I'm going to do is I need to fill in these last two spots. And I'm going to take them from here in the same order that they're here, as long as they aren't a 3 or a 1. This is, again, I don't like this order. Can I just please have it be? It's fine. It's fine. You guys are going to get the idea. 1. Should I put a 1 here? No, it already exists. 3. Should I put a 3 here? No, it already exists. 0. Should I put a 0 here? It doesn't already exist. 2, should I put a 2 here? Yes, it doesn't already exist. So what I wanted this to be is an order that's something like 1, 0, 3, 2. I would still get the same thing, right? Because I would say 1 can't go there because it's already there. 0 can. 3 can't go in the next spot, but 2 can. So I'm going to just pick a random part of the order and then fill in the rest from the other. I think this algorithm has a name for it. I don't know what it is. Maybe somebody watching can tell me. Okay, so let's actually implement that now. Okay. Let's look at that. So what did I do? I need to write this crossover function. Okay, so coming down here, I need a new function. I'm going to put it above mutate. Somebody's playing some music in the hallway. Crossover, order A, order B. So the first thing I want to do is I want to take a random slice of order A. So I'm going to say start equals floor random 0, comma, order A, just random order A dot length. And then I'm going to say end equals some value between start and the end of random A. I could always just take the first half or something, but this is just, I'm taking a random spot anywhere in here. So maybe I pick this spot. And then I want a random spot anywhere between here and here. And I probably should say +1, right? +1. Okay, so now I should probably say start +1, I think, because when I'm about to use slice, so I'm going to say new order equals order A slice start comma end. And I'm pretty sure that with slice, if I give it 3 as the start and 3 as the end, I won't get anything. Let's actually just look in the console to sort of see. Like if I have an array that's 0, 5, 0, 1, 2, 3, 4, A dot slice 0, comma 3. What do I get? I get 0, 1, 2. I don't get 3. I get 0, 1, 2. And if I said A dot slice 3, comma 3, I get an empty array. So I always want to at least get, and if I would say A dot slice 0, comma 5, that would be the whole thing. So I think that makes sense. Okay, now, what I need to do is figure out how many things do I have left. So I have a total number of cities minus new order dot length. So this is how many I need to add, right? Because if the total number of things should be 10, and I get this slice of 6, then I have 4 more that I need to add. So I now have a loop, I equals 0, I is less than left. Actually, but here's what I want to do actually though, is what I want to do is I want to say var, I want to actually loop through, I want to loop through the order B's, everything in order B, right? Because city equals order B index I. I want to know if new order includes, I think this is a JavaScript function that will tell me if it already exists in the array. Let's see. So this is my array A. A includes 2 is true. A includes 5 is false. So this is going to work for me. I can say if new order includes, and I'm sure there's some fancy super JavaScript ES6 array operation way to do this, and I look forward to hearing about that in the comments. If new order includes city, if new order does not include city, then new order push city. So I guess I don't need this left, because by definition, this should just work. If I've done everything correct, if I've done everything correctly, then this should have the right number of stuff in it. I think what I'm going to need to do is definitely just try this function out. So, and then at the end, I want to say return new order. So let's try this. So the program's still running as it ran before. I haven't actually introduced crossover, or did I? I don't think I actually put crossover in. Yeah. Oh, I did. So it's actually doing it. But let's see if this actually works. A equals an array like 0, 1, 2, 3, 4. And B equals, I'm going to say 4, 3, 2, 1, 0. So what I want to say is cross over A comma B. Let's just see what I get. 0, 4, 3, 2, 1. Does that make sense? I mean, it worked. It's a random order, but how is that a crossover? It must have only picked 0. Yeah, only picked 0 from A, and then it got 4, 3, 2, 1. Okay, that makes sense. Then it got 1, 2, 3, and then it got 4, and then 0. So this is working. This algorithm appears to be working. So now, is this actually improving anything? Unclear. Let's reduce. I think now we could really reduce that mutation rate because crossover is going to give us a lot more variation. And I would love to just increase the population size to the point as large as I can increase it without it running too slow. So let's try 500. So yeah, this looks pretty good. Like I'm kind of seeing it slowly over time improve. You know, how many cities is this? 10 cities? What if I put 20 cities? And let's give it some more space. Let's give this canvas like a bit more room to work with. And see what we get. Now, yeah, let's take a pause here, and I'm going to come back in a minute after I've let this run for a while. Okay, I was having a little rest there with my lullaby. And I'm back. So I let this run for a while. You can see that it's doing pretty well. It seems this is the best one it's found and sort of sticking with that for quite a while. So I'm going to see maybe we can do 1 or 2 more small improvements, and I'll give you guys some ideas of things you might do with the code to improve it, and then I'm hoping you're going to submit some user submitted improvements. Okay, so a couple things. One is that includes function that I'm using is actually part of ES6, which is a newer version of the JavaScript syntax that I'm actually using in most of my videos. And ES6 also has something called a set, which I guess is which could be a data structure that would be useful here other than just a plain old array. The other thing that I should mention is that the distance function that I'm using to actually calculate the distance, which is right here, this is a pretty inefficient or slow algorithm because it uses the square root. So one thing that I could do is create my own distance function that doesn't use the square root but just uses the squares of the differences because all I care about is relative distance. Or the other thing is there's a fixed number of cities. I'm only ever looking at distances between them. So I could create a lookup table that just pre-computes all those distances. So I'm just summing up what it is. But anyway, that aside, those are some things you might think about adding. There was a great suggestion in the chat from Cole Noxide second. I don't know what that name is, but that maybe what I should try in mutation is instead of swapping 2 randomly, actually swapping 2 neighbors. So where do I do mutate? So what if I pick index A and index B is actually index A plus 1. So it's the next one. And I could say if index B is greater than total cities.length, then I could say, or greater than or equal to, right? If I've gone off the edge, then I could say actually index B is index A minus 1. There might be a nicer way to do this. But so what if I only swap 2 that are next to each other? Would this be a better algorithm? Okay, so let's run this. We're going to lose everything we had from before, but I'm going to run this. Okay, so I made some sort of error here. Can't read property x of undefined calc distance. So there's something wrong with my, not total cities.length. Total cities is just the total number of cities. Let's fix that. Okay, So let's hope, I'm gonna take a little nap again, and I'll be back in a little while. So, by the way, I'm gonna let that continue running, but I realized this would be a nicer way of doing this would just be to use a modulus operation, so that I could just, because I could swap the last one with the first one, and so this would actually, I think, be just sort of a cleaner way to write this little bit of code. I don't want to necessarily rerun it because this has been running for a while. I don't know, did that improve it? Did it not? 20 cities is a lot. Let's feel better about ourselves and the world and the traveling salesperson problem. Let's just give it 12 cities. Which 12 cities? There's a lot of possibilities. 12 factorial is how many? That's 9,479,000,000 possibilities, which would take quite a while to iterate through all of the possibilities. But I have a feeling that if I run it with 12, we're going to get something pretty good pretty soon. Like really fast. That was like a pretty good, I don't know if this is optimal. Oh, found something even better. Oh, I'm pretty sure, oh yeah, I could definitely make it better by going from here to there, then to there. So anyway, hopefully it's going to get even while I'm talking, but we've done something that works pretty well. So here's my request to you, the viewer. Please, once I post this code, go to the link to the code. There'll be a README file there. If you make an improvement, add a link to your improvement in that reading file with a pull request. If you don't know how to do that, well, I do have a video about how to make a pull request, but just write a GitHub issue comment or tweet at me at Schiffman. I would love to see a couple things. Number one, I would love to see what kind of things can we add to this to make it more optimal. Maybe there's a better way to do mutation, a better way to do swap, a better way to do crossover. So what can we add to this to make this optimal? The other thing that I would really have to think is, what is a better way to visually tell the story? This isn't really so great. I'm kind of seeing like a bunch of random stuff and sort of the current best, but could I see the full population of everything? Could I watch a graph of how it's improving? Could I see some annotation? Is there some interactivity to sort of speed it up and slow it down? So I would love to see variations and ideas for how you can tell the story of this problem and how the algorithm is working. So thanks for watching these videos. I finally did it. I have completed, I think, the set of videos about the traveling salesperson problem, and I look forward to hearing your comments and questions in the comments on YouTube. I think, somebody told me I should remind people to like and subscribe. So please like and subscribe. There could be like an end screen thing popping up around me. Maybe we'll add that in. Like and subscribe. Maybe you watch these next videos, and I'll see you in a future video, I hope. Okay, talk to you soon, or on, whatever this is that we're doing here on the internet. Did it fix that? No. Oh, wait, looks like maybe it got better. No, it should go up here and then there. That would just be so much shorter. Okay, I'll stick around and watch it. I'll tell you what happens another time. Goodbye.